Okay, let's proceed with question 4. Tuto induction machine ELE291. Number 4. So this is the different type of question compared to the first 3 questions, whereby you are given with the value of state RS, RR, XS, XR, XM, and XM. So let's solve it together. So first, 280 volt is the V phase. Okay. So frequency 50 Hz. Okay, horsepower. So that is P mechanical. Sorry, P mechanical. P out rated. So horsepower is the unit for mechanical, and for induction motor, P in convert into P out, P electrical converted into P mechanical. From what we convert into horsepower. So that is P out rated. Okay, in horsepower. For pole, number of pole 4. As the following equivalent circuit parameter. Okay, hold that for a while. So given also the rotational loss. The rotational loss 400 watt and also 5% of slip. Okay, S is 0.05. So convert into decimal 5/100, so you get 0.05. Okay, draw the equivalent circuit and determine. Okay, for this kind of question, I will usually suggest the student to sketch first so that you can see what you are calculating actually. So this is the approximate equivalent circuit for induction machine that we are using. As you can see, I didn't draw the RC because it's not given here. Okay, so we assume that the RC is too large and that it will become open circuit. Okay, so we are only left with XM, that is 10 J ohm. That is XM. RS JXS JXR RR over S. So then you label RS 0.12 ohm, RR 0.1, XS and XR is the same 0.25 G, 0.25 G ohm, XM 10 J ohm. So in front here you will have V phase. Just like in your notes, I1 phase, I0 phase, and I2 phase. Okay, so let's answer this. Okay, we'll start with A. The motor speed in RPM and radian per second, so NR. We'll start with this formula. NS over slip equal to NR, NS minus NR over NS. So this is what we want. And we can calculate NS. And S is actually given. Okay, so calculate NS first. 120 F over P, that is 1500. That is synchronized speed. Okay, so now you can calculate NR. S is 0.05 equal to 1500 minus NR over 1500. So NR equals to 1425 RPM. So in radian per second, we write it as angular speed. So you have to times with 2 pi over 60. You will get 149.23 radian per second. Alright, so A done. B, the motor current. So the motor current is I1 phase, okay? The I1 phase equal to V phase over, in this case you don't have RC, so XMG plus, okay, sorry. I1 phase equal to I0 phase plus I2 phase. Okay, then I0 phase is V phase here over XMG because you don't have your RC, plus I2 phase is the same V phase, but you have to divide with 4 series component, that is RS plus JXS plus JXR plus RR over S. Okay, so V phase 280 over 10G plus 280 over 0.12 plus 0.25G plus 0.25G plus RR over S 0.1 over 0.05. Say 0.05. So this is actually 0.1 over 0.05. Equivalent to 2. So this one is equivalent to 2. So solving that, you will get 28 at angle of negative 90 plus 128.55 negative 13.27. So that is I0, I2. So your I1 is 137.7 negative 24.69 ampere. Okay. So I1 phase or motor current done. B. C. The stator and rotor couplers. PSCL, PRCL. Okay, so if you got this question whereby you are given with all these components value and you have all the current I1, I0, I2, so most probably you will be using the formula. So you may refer to your note. PSCL equal to, is the losses here. PSCL is the losses at stator. Here. Okay, so we can see that the current that flow through the stator resistor is I2 phase. So I2 phase squared R stator. So I2 phase ni this one I2 phase this. Okay, but only take the magnitude, that is 128.55. Because real power has no angle. RS is 0.12, 1.983 kilowatt. While PRCL, rotor copper loss, is the loss at RR, rotor resistance. So rotor resistance, although in this equivalent circuit it is combined to become air gap resistance, but if the question asks for rotor copper loss, since rotor is also located at the back here, so the current that flows through it is still one I2 phase. So the formula will become I2 phase RR. Just take RR sahaja, rotor resistance 0.1. So you will get 1.653 kilowatt. Done with C. D. the aggregate power. The aggregate power also has formula. That is I 2 phase squared. Or in other words, the losses dekat on this resistance or RR over S. Okay, so I2 phase squared times RR over S. Ataupun 1 to 8.55 squared times 0.1 over 0.05, that is 33.1 kilowatt. Okay, moving on to E. E is induced power. Induced power is similar or is the same as P developed power. So developed power, usually when you already calculated PI gap, we will usually use this formula to get PI gap. So 1 minus S is 0.05, PI gap 33.1 K. So the answer is 31.4 kilowatt. Okay, F plus 1 is the efficiency. Okay, for the efficiency, as for now, we don't have the both value P out and P in, right? So we need to calculate. So it's more convenient if you sketch first your power flow diagram. Okay. Because the formula for P in and P out is not it's not in this diagram. You cannot simply use I squared R for P in and P out. You have to refer to the power flow diagram. P out, P develop, P gap, P in. So P core loss, P SCL, P RCL, P max loss, P miscellaneous. Okay, so whatever power which you have calculated earlier, you just label. For example, ni PSCL, PRCL, P air gap, P develop. Okay, this one you cannot label first because this is rated value. So, but in this question until now, it is not stated whether this motor is operating at full load or at rated condition. There's no such statement, so you cannot simply use P out equal to 20 HP. Okay, but first let's label the value. Okay, 1 minute. PSCL 1.983 kilowatt. PRCL 1.653 kilowatt. P air gap 33.1 kilowatt. P develop 31.4. Okay, the rest, if it's not given, okay, this one given, P rotational loss, don't forget 400 watt. It's here. And because P mechanical loss can be friction and windage or rotational loss. So friction and windage not there, so we assume 0. P rotational is 400. So P straight of P miscellaneous not stated, so we assume 0. Same goes for P core, it's not stated, so we can assume 0. Only for these three, P core, P mechanical loss, and P miscellaneous or P straight loss. Okay, so the question asks for efficiency. Means you need to calculate what is your P out and P in. Okay, from here, I immediately see that we can calculate P out, P developed minus P mechanical loss, you will get P out. P rotational lah, okay, because this is 0, 0. So 31.4K minus 400, you'll get 31 kilowatt. While for P in, yes, P air gap plus P SCL plus 0, you'll get P in. So 33.1K plus 983. Okay, so you'll get 1 minute. You'll get 35.08. Okay, so your efficiency now is 31K over 35.08K times 100. 31 over 35.08. That is 88.37. Okay, so that's it for this question 4. So from question 1 until 3, okay, there can be two types of question, whether the question give you RS, RR, XSSR, SM or not. Okay, so if it's given, so you have to solve it like question number 4. The question will definitely ask you to find current. So you will get the current, and at the end, most of the power you will be using the formula. But for the question 1, 2, 3, whereby it's not given, so you play around with the formula which you can use that does not involve value of R or current. For example, a formula using SPI gap, PW equal to 1 minus SPI gap, and that one you can use, or you can play around plus minus the power flow diagram for question 1 until 3. Okay, that's it for this video.